Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. I'm Zeeshan Haider and I'm here to present to you my analysis on Azure Industrial IoT model. So without any further ado, let's dive in. Platform as a service. Without starting or jumping to the main points about what Industrial IoT model does, or what modules does it use, or what approach does it follows, it is necessary to know the basic knowledge, the baseline which relies on platform as a service. Platform as a service is a service with a complete development and deployment environment in the cloud. It contains all resources which enables you to deliver everything from simple cloud-based apps to sophisticated cloud-enabled enterprise applications. In platform as a service, resources are purchased from a cloud service provider on a pay-as-you-go basis, and a secure connection is used to access it. Among other cloud services, platform as a service includes infrastructure servers, storage, development tools, business intelligence services, database management systems, and more. PaaS is designed to support the complete web application lifecycles, as it can be seen on this chart. Platform as a service is designed to support the complete web application lifecycle, from building to testing an application to deploying and managing its services, and later updating and patching on a later stage if required. The bigger advantage the PaaS covers is that the user only manages their applications and services they develop, avoiding the expense and complexity of buying and managing software licenses, or without having any knowledge of what underlying infrastructure or development tools are being used during the provision of services. As can be seen in this comparison chart, we can see that platform as a service provides all the services that infrastructure as a service provides, including data center, network and firewall service and storage, including operating systems, development tools, DBMS, etc., which infrastructure as a service doesn't. In PaaS framework, PaaS provides a framework that developers can build upon to develop or customize their cloud-based applications. Users can create applications using built-in software components which is provided in that service. Features such as scalability and high availability manages and helps reducing the amount of coding time that developers usually face. Business and analytical tools allows users to analyze and mine their data. In return, predicting outcomes to improve forecasting, their product design decisions, investment returns, various business decisions. As earlier described, platform as a service allows users to cut coding time, aid development capabilities without adding staff, develop your applications for multiple platforms, including mobile, and efficiently manage application lifecycle as required. Moreover, the flexibility of working remotely on projects makes platform as a service, cloud service, a better choice as compared to a legacy data center architecture. Industrial Internet of Things. In Industrial Internet of Things, it is an evolution of a control system that allows for a significant improvement in automation. It is an evolution of mining and turning data into information. This period of evolution is called Industry 4.0, and IIoT mainly concentrates on connections of machines and devices in industries like manufacturing, healthcare, and logistics. Internet of Things versus Industrial Internet of Things. Whereas Internet of Things is commonly used to define consumer-based devices like Fitbits, smartwatches, and various other smart home devices like thermostats and alarm systems. Whereas in Industrial Internet of Things, It is mainly about getting information needs in their hands when they require, when a consumer wants it. Also, industrial Internet of Things is used in the production environment. That is the industrial or the environment that the factories uses, unlike the home environment. So the question here arises, why is this major transformation is required, or what benefits does it provide? Uh, the answer to these both questions could be that in this fast-paced and competitive environment, every company wants to perform better, increase their efficiency, have better inventory control, and provide just-in-time manufacturing, meeting higher customer demands. Uh, so therefore, all these efficiencies can only be achieved with the help of a digital twin. Digital twin is actually a virtual representation referring to a digital replication of an actual company, their physical assets, their processes in places, and automation systems and devices. The twin uses real-time data to enable learning and reasoning for improved decision making. The twins also allows experimentation with new information that is generated without having to shut down production. The twin also ensures better security since all tests are being performed in the virtual environment without disturbing the services in the production environment. And digital twin can also be used as a training ground to train new employees without impacting live services. So finally, the main topic that we had to discuss is the Azure Industrial IoT. Microsoft Azure Industrial IoT is a suite of Azure Cloud microservices and Azure Internet of Things Edge modules. The cloud microservices ensure security and integrity of data on the cloud end, which is at the ISP, or we can say the service that Azure Cloud provides. And whereas the edge modules residing at the factory end ensure sharing of data from those sensors that are being generated, and it is also responsible to forward those shared data to the cloud, which is the Azure Cloud microservice. Azure Industrial IoT integrates the power of the cloud into industrial and manufacturing platforms, providing the ability to integrate data from assets and sensors into the cloud, including those that are already operating on the factory floor. Some applications of Azure IoT could be the following, but not limited to these only. Industrial IoT analytics applications can support the following business practices, which are asset monitoring, anomaly detection, overall equipment effectiveness measurement, predictive maintenance, and forecasting. The following architecture diagram shows the core subsystem that forms an industrial IoT analytics solution. We can see that a control network of industrial devices sends data to the cloud through an edge field gateway. That is number one over here. The gateway sends data to a rules and calculations engine. Further, the calculation engine sends data to microservices or to machine learning module. Data services also include time series services and asset hierarchy. Later insights microservices trigger actions like notifications, business process integration. Insights also handles powering visualization, including like schematic views, trending, dashboards, and notebooks. Automation companies are required to be fully experienced with an organization layer of systems, such as described in the automation pyramid model as shown in the preceding slide. Also, an industrial IoT analytics solution relies on real-time and historical data from industrial devices and control systems. Those systems are industrial equipments, which is our sensors, our actuators, uh, and the second level, as shown on the pyramid model, automation pyramid, are PLCs, programmable logic circuits. Later, those data are further processed using SCADA systems, MES for warehouse control, and ERP for accounting systems. Moreover, integrators are required to have expertise in machine learning, data science, and real-time analytics. Industrial IoT components or the solutions. The solution is actually built from specific components, including having at least one Azure IoT hub, an Azure IoT Edge device, and industrial edge modules. Basically, IoT hub is a central message hub used for secure bidirectional communication between Internet of Things applications and devices it manages. It is a product and an example of a platform as a service model. Data gathered from Internet of Things hub can be efficiently analyzed, processed, and combined with other Azure services and tools, for example, Power BI. Azure Internet of Things Edge, IoT Edge is composed of an IoT Edge runtime and an IoT Edge module. Here, Edge modules are Docker containers, which are considered to be the smallest unit of computation. And Edge devices are used to deploy such modules. In short, these devices act as a mediator between the OPC Unified Architecture Server, which resides on the factory side, and IoT Hub, which resides on the cloud. As depicted in this in this architecture, the data gathered from sensors and actuators are managed and processed using various microservice modules prior to being processed to IoT Hub in the cloud. There are multiple modules in the IoT edge device which are used for specific tasks, which are used to process and perform calculations on the data gathered from these actuators or sensors prior to being sent on this Azure IoT Hub on the cloud. The task of OPC Publisher module is to connect and share data from OPC Unified Architecture to Azure. The OPC Unified Architecture is basically a server which is used to gather data from all the sensors. Later, those data gathered from the sensors are processed and sent to Azure client end, and later those data are being sent on the Azure cloud. OPC Publisher operates in two modes. Number one, that is orchestrated mode, which is controlled by the Industrial IoT Cloud microservice. And number two, standalone mode, using a local configuration file to allow operation without an Internet of Things microservices. To further explain, Open Platform Communication, which is OPC, which stands for Open Platform Communication, is a standard which is designed for secure and reliable exchange of data in the industrial automation space. OPC ensures independent and seamless flow of information among devices from multiple vendors. This app specification also defines the interface between client and servers, server-to-server connection, real-time data monitoring of alarms and events, and access to historical data. OPC basically is responsible for the development and maintenance of this standard. OPC Unified Architecture, which stands for is a specification basically used to address security and data modeling challenges. Actually, with the standard or introduction of service-oriented architecture in manufacturing systems, new challenges started to surface in security and data modeling. Later, OPC Unified Architecture had to develop to address all those needs. Moreover, and also to provide a futurist technology open platform that is scalable and extensible. Discover, register, and manage industrial assets using Azure. Azure Internet of Things provides a set of microservices that is used to connect to OPC UA system on the shop, which is on the factory side. Uh, REST APIs are used to enable cloud applications to browse OPC Unified Architecture servers address space, read and write values of OPC Unified Architecture nodes, and execute OPC Unified Architecture methods. Managing network security, the communication between the devices through certificates. In a converged environment, to enhance security connection among devices, it is necessary to define policies to restrict which clients should be allowed to talk to which server. Azure Certification Management does that. To conclude, many organizations are still concerned about investing so much in industrial IoT. However, on the bright side, the benefits of industrial IoT in manufacturing, pharmaceuticals, agriculture, mining, oil and gas, and retail are going around, and many companies are embracing this new paradigm for solutions in optimizing operations and personal productivity. For further suggestions, feel free to comment below. Thank you for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.